Hey everyone, today we're going to be looking at a Lexicon PCM 70 digital effects processor. The one I have here has seen better days. It's in pretty bad shape. It's got a handful of buttons moving off the front. There's no screws in the case. It's dirty, it's filthy. The rack ears are beat up. There's no actual screws in the front either. So it's not in good shape. These effects processors are very, very popular effects processors even today. Working ones will go upwards of $500, used on eBay, just because of the sound. A lot of people love especially the reverb on these. It's just a really, really nice reverb, very, very renowned. But this one is completely dead, so I shouldn't say that. It's got no display. That's pretty much it. You plug it on. When you power it on, sometimes some of the lights will come on. Other times you'll get some of your actual input level meter there will light up, but that's about it. So there's no response from any of the buttons, and that's all as far as I can tell that it does. So I'll plug it in again real quick just to see. Again, it powers up, but no display, no button response at all. It'll be random. Sometimes you power it on, there'll be nothing. Other times there will be, in terms of the lights on these buttons here. Anyway, I'm going to take it apart, take a look at it, see if it's repairable. It might be repairable. We won't know until we look inside. Again, I don't know if someone's been inside this one already too. That's always the scary part of buying stuff like this. Usually there's three states of things these will end up in. Number one, end user has it, and it's been used on the road for years. It got beat up, it died, sat in his closet, whatever, throws it on eBay, and now it's mine. Two, somebody that doesn't know what they're doing tried to fix it and ends up damaging it even more than it was, or possibly stealing parts from it, which would be pretty much done at this point. Or three, somebody that does know what they're doing attempts to repair this and either confirm that it's beyond economical repair, or that something is wrong with it that you can no longer obtain. For instance, the DSP chips in here are proprietary to Lexicon. If they're dead or blown or missing in that case, then you're not going to find replacements for them. It is kind of a shame the buttons are missing on here, because I'm not going to be able to locate those either. So, unless I find another parts unit for it, to steal them off there. But I think this will be repairable. The nice thing about these old ones, these came out in the 80s. And the whole PCM series, there's the 60, the 70, the 80, a lot of other different models in there. I don't know the whole history of them. But they're all just standard, TTL type logic in here. Z80 microprocessor based, old school Burr Brown DACs. Nothing difficult to repair. It's just they're actually fun to repair because it's kind of it's a fun game, especially if it's a logic issue, which this one might be. Again, we'll take a look inside, see what's going on, and go through the repair, because hopefully it is repairable. So here's a look inside the PCM 70. Again, classic 80s, 90s design, all TTL-based logic, Z80 microprocessors, so it's really, really cool. We'll walk through real quick what's going on inside here. So, back section, you've got power supply. It's a simple analog supply, no switching in here. Power comes in, goes through some basic input filtering, power transformer, first goes through your switch, power transformer out, rectifiers, and then a couple supplies. Like most of this older gear, you've got your positive negative analog supply for the analog section and the digital analog converters, and then you've got a plus 5 volt regulator, which we have in the back here. So there's three regulators: 7815, 7915, and essentially a 7805. Among that, you've got basic power supply filtering, nothing special, and these caps. So the capacitors in here actually don't look bad. We won't know for sure until we take them out to see if any of them been leaking, but these two over here are not leaking at all. They are, let's see, I can't see the make on there, but they're 105C rated, which is good. So these bigger ones are Nippon Chemicons, so they've got good caps in here. But it's probably not going to be a power supply based on the look of this, so it's actually pretty clean in here. But if I do end up fixing this and able to restore it, part of the restoration process is I'll go through and replace the electrolytics anyway, because because age. This thing is from, I don't know the exact date on there. Actually, there's a date right here. So 1986. So 1986 was at least the date on the board. If we can look at some of the chips for date codes on them, we got 22nd week 89, 24th week 90. So at least 1990 was when this thing actually was built. So almost 30 years ago today, so quite a while. Architecture inside is actually very similar to the LXP15 by Lexicon that I did a repair on as well. I've got a video for that. So we've got the same kind of setup. There's two Z80 microprocessors. You've got the master and the secondary. The master controls basically all the functions of the unit in terms of updating the display, reading the scan codes from the input buttons, and controlling the input encoders to basically control the rest of the unit. The secondary Z80 is there to control strictly just the DSP. It's the one that actually switches the DSP algorithms and controls basically the functions, everything involved with DSP. That way it can run more in real time for that and leaves the master processor here to run the rest of the unit. Besides that, there's actually 3 EEPROMs in here. There's one tucked up in the front here, and we got the 2 sitting back there. So they're labeled different versions. Version 2 on this one, version 1.2 on that, 1.21 here. So I know that there was different software releases for this. 1.2, I believe, was a later one on PCM 70 that fixed some bugs in some of the DSP algorithms. Moving on, so we have digital section over here. So these chips are all branded Lexicon and high-speed processor. So these are your DSP in this area here, which makes sense because following that we've got our Burr Brown DAC. So PCM 53, another classic Burr Brown chip. In terms of the analog to digital converters, it looks like that's this over here. It's actually an Intersil chip, an ADC0804. Now that actually might not be the ADC for the actual analog input. That might just be a ADC for monitoring the levels to make sure you're not clipping. A lot of times on these they'll actually do a delta sigma type analog digital conversion. So we'll have to look more into the data sheet or to the service manual for that to see how that works. Which actually for this model too, I forgot to mention, the service manual is available. So I do have a copy of that, which will greatly ease or make the troubleshooting process easier. Besides that, there's just a whole bunch of TTL logic, which I love. So that's again what makes these things fun to work on. Over on the analog side here, there's definitely an obvious separation for analog digital power. They even have the supply buses labeled on the board too, which is kind of nice. But so on the output of the DAC, you've got your analog filtering through these filters here, and then along with some op amps, and then probably level control going to the outputs on the back here. So, plus there's mixing as well. With these devices, you can control the mix if you want the the actual effects to be 100% wet or all the way or completely dry. So that's adjustable as well. Anyway, to start troubleshooting, first thing we'll look at is the supplies. I mean, the first visual inspection, I have to say, nothing looks missing, which is good. All the chips are there. Nothing looks burnt. Nothing looks broken. I don't see any mechanical stresses. I looked at the bottom of this too, off camera, and everything looked fine. These Lexicons are great to work on, by the way, as well, because both the bottom tray comes off and the top tray, so you don't actually need to remove the board to do any work on them whatsoever. So we'll check the power supplies. They've got taps here to actually measure all the supplies, which is really, really nice. And if that is unsuccessful, the supply voltages are good. We'll do some basic checking. We'll check the crystal, make sure we got clock coming out of there. We'll probably reseat the EEPROMs and some of the microprocessors just to make sure that they're seated correctly and there's good connections. There's no corrosion in there causing them to operate incorrectly. We'll check the power supply as well for ripple. Make sure that we're in spec on this and that some of these caps actually aren't bad and leaking a lot of ripple through to the actual unit. And that's it. We'll start there. If none of those are successful and everything is within tolerance, then we'll start looking at the data sheet for troubleshooting this guy. Alright, checking voltages is the next step. So we'll be looking at the taps back here. And starting with plus 15, we look good. We'll go minus 15. A little low, but we're good. And then plus 5. 509. So we're good. Power supply voltages there are good. Anyway, so I will check for ripple, then I'll also check that crystal. Alright, so there's actually a jumper on here labeled master clock, and this crystal is 13 megahertz. So probing it, we have 13 megahertz. So the crystal is good. Alright, I'm going to be probing around in this Lexicon a little bit, so I can't get the camera both on my scope up there on the bench along with the gear, so I brought another scope over. That way it can all be in frame, which will be nice. So I just checked for ripple. Everything is good. The data sheet actually states the specifications for ripple, and everything is within spec. There's less than 40 millivolts of ripple there on all the lines, which is good. A little bit of noise, but nothing to worry about. Like I said, I'll probably still replace those caps when I'm done there. I've still got nothing on this, no display, no response. It's going to be time to start digging into the digital circuitry. The one thing I did check too was there's actually a high voltage supply that runs this VFD. It's actually a vacuum fluorescent display on the front here, and that high voltage display or lines going to it is good. So I know I got power to the display. It's just not lighting anything up, which would still indicate it's a digital issue going on in here, which is good because those are fun to solve. I'm going to go to the data sheet and start going through the troubleshooting section, and it kind of walks you through some basic areas to check to see what's going on. It'll start having you probe certain pins on the microprocessor looking for clocks. It'll have you start checking the interrupt lines for activity on those. It'll start having you also check things like, actual data activity on the data buses and on the address buses. There's the reset pins as well. It'll make sure that those are in the proper state, to make sure they're actually high, they don't go low. So there's a handful of things that I'll check going through this to see if I can, help isolate down exactly what area that is having the problem. Alright, so back to the data sheet, going through it. A lot of the troubleshooting section starts with the actual onboard diagnostics. There's a jumper here where you can put it into a test mode, and then there's various other button presses you can do during the boot up sequence to put it in modes. But since I don't have a display, none of that's good for me. Scrolling down, I did find a section in the service manual regarding no display, garbled or stuck display, which is what I have. So first thing it does is it has you check the master clock, which is U28, the Z80, pin 6. Which is here. So I've got my master clock, which is good. Then it has you check for the non-maskable interrupt on pins 17 and 26 on that same U28. Those lines have to remain high. If they go low, it goes into basically a fail-safe. So the fail-safe circuitry inside will bring it low if something's wrong. So pin 17 and 26. Coming backwards. There. Right, that's high. And then 26. That's also high. So those are both high, which is good. It has you check for basically data movement on the Z80 across the data and address pins, which I have. I've got all sorts of data moving on these pins, which is good. So following that, it says check pin 11 of U27, U39, U38, and U51 for clocking of displayed data. If there's no clocking, U59 may be the cause. So U27, U39, U38, U51 are right here. There are these 4 chips right in a row. And they are in line with the display driver circuitry right here. So those are 74 273s, which are flip-flops. So they handle some of the clocking of data into the display, I'm guessing. Probing pin 11, I'm not getting any clock on any of them. Shows pin 11. Pin dips. Yeah, it's pin 11. Got nothing. So, in the event of that, it says U59 may be the cause. So U59 here, 74 138. I can't remember offhand what a 138 is, but I know I have some. So let me pull up a data sheet for that chip real quick. So 74 138 is a 3 to 8 line decoder, and that's this guy here. And I have the service manual for this, but it doesn't have a schematic. So that's part of the driver circuit here. So it's probably the clock's coming off here, and it's sequencing these to drive the display, or at least clock in the data for the display. I'm not exactly sure, but we'll just kind of probe around on it a little bit. Not really seeing much data there. You should be seeing all sorts of clocking on this on the pins coming out. So I wonder if that's our input. Noisy clock. That's pin 5, which is... Can't see the data sheet from here. So we've got clock on 1 through 6 basically. At least some type of data. Not 4 though. Alright, now I took a peek at the data sheet. So pins 1 through 3 on this are actually your address lines. So we've got address data on here. And then pins 4 through 6 are your enable lines. So high, got data, data. Then pins, basically all the other pins essentially, 7, skipping 8, 9 through 15 are all the outputs. Oh, there's one. I'm on the wrong chip, never mind. These are all just high. I can't see anything off of there. Not high speed or low speed data. So I'm curious. I mean, the service manual states that in the exact event that I don't have clock on pin 11 of any of these chips here, this is the fault. And this seems to be operating erratically. So it might be worth trying to swap out. I know I have some, so it wouldn't be a big deal. So got a small bin of 74138s. Most of what I have is just standard TTL 74138, not even like a LS or an ALS. I do have some. There's an LS. There's an ALS too, actually, I just saw. There's an ALS, lower power versions. Anyway, the one in here is a HCT, which is actually a CMOS derivative of it, which is TTL compatible. So I don't know why they chose that. I haven't looked at the full specs on the data sheet. These aren't running at a high clock speed, so I'm going to pull this, throw in a socket, and then I'll try some of my 138s that I have. Alright, chip came out pretty easy. It's always you have to be careful with these layered boards to make sure that you don't damage any of the pads or traces, or rip off a trace for that matter. So, put the socket in now. No difference in display. Let's see if we have data on those pins. There's a clock there. Trying. Alright, so I stopped troubleshooting this based on the troubleshooting instructions that I have in the service manual, because I've gone through the steps that they suggested to try to isolate the problem. So far it's been unsuccessful. So I stopped and did some research to find the schematics for this unit, which I ended up finding, luckily. It actually wasn't that hard. I just didn't look hard enough the first time. I figured the service manual would have them. It did not. There's 2 additional manuals that actually have all the schematics for it. So that said, I can start looking into what the problem is, and I have the schematics, so I can start tracing at least, instead of going down the guessing game of just starting to pull chips out everywhere without really knowing, I can actually see and have an educated guess here based on the schematic. So the problem I've isolated so far is with U59. And that is the decoder. I've got inputs coming to it, both on, or I should say, I've got inputs going to it from the 3 selector pins, and then there's 3 enable pins. And 2 of those 3 I've got data on, and the 1 pin I did not, pin 4. So on the schematic here, this is U59, the chip that was in question. And here's my 3 select pins for the decoder, A, B, and C. I had clock and data on all 3 of those pins. Then I had my 3 enable pins here, 4, 5, and 6. And 5 and 6 had data, but 4 was stuck high. So based on the service manual itself, this was the chip that to look into, that 74 HCT 138 that I pulled, as this drives the actual display decoding. So this pin here, IORQ, was stuck high. I wasn't getting any data on there. So now that I've got the schematic, I can see exactly where that goes, and as a test, I basically just pulled, since I already pulled this chip out and was socketed, I lifted pin 4 off the chip, so it's not actually in there, in the socket anymore, and I'm able to power the unit on now, and on all the decoder outputs, now I have data, which I didn't have before. So something is holding that pin high on that line. And now that I have the schematic, I can trace it. And there's only a couple things on here that pin actually ties to. So the Z80 microprocessor itself is where that pin actually originates from. Where is it? Right here. IORQ on this bus. And on this bus, there's only 2 chips that basically use it. So the decoder, U59 right here, that is on pin, what did I say it was, pin 4. And also this U71, another exact same decoder chip, pin 4 as well. So, no, I traced the bus on the rest of these chips here, and nowhere else actually uses the pin, just these 3 locations. So either the Z80 has a problem holding that high, which I don't think is the case, because I swapped the master and slave processors. They're the exact same chip, and there was no difference in there. This chip I've already pulled, which leaves U71 here, another 74 HCT 138 that could potentially be problematic, holding that pin high. So at this point, I'm going to try pulling this chip as well to see if that makes any difference. Now I will note, even though I've got data on here, I still don't have any display. So the other thing to note too is, since lifting that pin, or that pin 4, now on pin 11 on these chips, like the data she mentioned, I've got data. That wasn't there before. So all the way down to the actual display drivers, I've got data going to the display. So I could have a bad display. That is still a possibility. I'm kind of leaning towards that, because one thing I'm noticing on this too, I measured the display itself in the high voltage lines, and I've got power going in there within spec based on the service manual. But usually on these VFDs, you can see the filaments slightly glowing, and I'm not seeing that on this display. So the display might be problematic, but I don't think I've solved that problem yet, because I've still got no response on any of the input buttons. So it doesn't respond at all. I can't, none of the lights enable. And every now and then too, on random power ons, these lights get stuck. So it could be something with that pin on the Z80 being stuck high. I'm not sure. I'm going to pull that other 74138 and see if that solves the problem. So I lifted that pin here. I got it in the socket down right here. I don't know if you can see, but no difference still. So with the pin lifted there, I do have data on the outputs of this chip as well as this one, but there's still no functional operation. It's not that pin is still staying high off of the C80, which I pulled all the chips out. I tested it. It's not stuck to ground. It's not stuck high. So this Z80 is actually not lifting, or it's not sending that pin low for some reason. So, strangely as it sounds, you know, the only question I have is the Z80 bad? Which means, are they both bad? Because I've swapped these a couple times, and they both have the same symptom as far as the output. One other thing I checked was all the EEPROMs. I pulled them off, put in my reader, read them in, verified the checksum matched, which it did. So I know my EEPROMs are good at least. So I feel a little bit stupid about this. After going through this the last time, I still wasn't getting any display. I thought maybe I should just take a look at the display and make sure it's okay. So I looked at the display previously. You know, I can see the whole thing, the back of it right here. Everything looked fine. It didn't look cracked or any problems from the back. It is a vacuum fluorescent display. But I pulled the front panel off to take a look at it from the front, and sure enough, it is cracked. So something happened right here, and it lost vacuum, which is why also I'm not seeing the filaments flow, which I kind of hinted on earlier. But the good news is that displays for this are actually still available. You can find them brand new, which is nice. So I purchased one, and I'm going to replace it, and then we'll power it back up and take a look and see if I actually have some display now. The data indicating on these display drivers, I should have display once I replace this. So that might be all the problem in terms of now at the state that I'm at. So here's a comparison of the old display and the new display. You can see the crack up on the top right here, top right corner. Again, I probably should have just looked at the display right when I got the unit to realize it was bad, but it wouldn't have mattered anyway. I had other problems to resolve before I got to this point. So regardless, we'll replace the display and go from there. Alright, I have the unit back together. Now we are going to try powering it up. And we have display, but there's still no actual usable data. It's just kind of in a lockdown state. And then similarly when I turn it on sometimes, just like I get some of the buttons over here locked in a certain state, I'll get the same on the display. Certain characters will be missing, or only a couple characters will show up, even though it's not doing it now. But it just depends on whatever state the logic ends up in during the power on process. So the display is fixed. I can continue debugging the logic at this point. At least I know now why I no longer have display. So I've been going through the schematics and just kind of observing some of the signals on the different chips and buses inside here. And there's something I noticed between the two Z80s. So the slave processor, if you look at the data bus, the data looks like it should. You know, it looks like high-speed data. Almost, you know, a little over 4 volt, almost 5 volt swing for a TTL, which is what it should be. Now, if you compare that to the master processor, same data bus, or same pins for the data bus for the master processor, and it doesn't look anything like the other data bus. It's almost like something is holding these pins high. It's not getting the full swing down to, you know, low enough below 2.5 volts to probably trigger, you know, the TTL logic and CMOS logic on this board. So looking at the data bus, I was curious, you know, what, maybe there's a bad chip on there, and I started pulling chips off, just seeing if anything made a difference as far as the RAM, the ROMs, this IO control over here. And I keep coming back to these 74LS273s. These are part of the display driver circuitry. They're basically just a quad flip-flop inside each of these packages. And these are driven off of that U60, the decoder that I replaced earlier. So the decoder lines directly go off there, and that's what sequences these. There's 2 chips that actually handle the columns and 2 chips that handle the rows on the actual VFD itself. So looking at the pins on there, you can see the clock data on them, except for this chip. It's got the same low signal compared to the other 4, which is odd. So I don't know why that is. I'm curious if one of these is part of the problem. At the same time, I went through a bunch of other circuitry as well. I traced down the actual reset circuitry to make sure that was actually working well. I traced down the clock circuitry again to make sure that was working as it should to all the chips. I then traced, there's a separate hold circuit when it powers on that waits until everything's powered up and stable, clock is stable, before it actually enables the microprocessors and a couple other chips on here. That circuitry all lives up in here. The service manual mentions it a little bit, so I followed their guides in terms of checking what's going on, and it's primarily made up of this circuitry right here. So you've got just basically a flip-flop that actually holds the state. There's a couple different logic lines that come in that goes through these, which are essentially become inverters, out to the actual reset circuitry back to the microprocessor. So I thought there might be a problem in here somewhere with the circuitry, but it ended up not being the case. Everything there seems to be working fine as well. So I'm going to keep probing around, but I'm really curious about this flip-flop on the display driver, because I feel that something is holding the data bus down, or holding the data bus high off of the C80, and that in turn is causing the data not to sequence correctly in terms of driving the display and running anything on the front panel here as far as what the master controller operates. Again, I tried swapping the Z80s. There was no difference there, so I know it's not a Z80 problem, I don't believe, because the secondary is working just fine, but something's definitely odd with that. I'm going to keep looking there. Okay, it looks like I've got some good news. I pulled the 74HCT273 out of the actual circuit. This was a chip that I was suspecting was causing problems on those data lines, bringing them down. So I just have it removed right now, and powering up the unit, I actually get response and data and display, which is awesome. So it's only, the display is complete because obviously that chip is gone. That chip drives a portion of the display in terms of what segments are actually there. I'm also not really getting much response from the buttons yet, which is okay. Actually, I need to system reset. I saw it said system reset there, which is kind of interesting. So I'm getting somewhere though. I'm making progress, which makes me happy. With that chip removed as well, probing the data lines on the Z80, I've got actual real data now, which is what I should have. So I'm also really happy about that. So I need to see if I have one of these flip-flops available. I don't know if I do or not. I'm going to have to go through some boards and see if I can find one. I've got a ton of TTL logic laying around, but it looks like that chip might have been the culprit, which would be awesome. Powering this up one more time, you can make out a couple things in display. This looks slave, possibly test error. I'll have to check into that. When you first power it up too, the first part of the display actually looks like it said version to state the version of software that was actually on there. So after it boots up for a minute or so, the buttons will actually start responding. So clear something, something test, test. So it looks like I can get into the actual menu. Regardless, before I do anything further, I'm going to replace that chip so I can have full display, see what's going on, actually read the messages in their entirety. And then from there I can start going through and system reset, I saw that pop up there too, and actually go through and be able to diagnose any other issues. Again, now that I have the digital portion working of the master processor, there might be other issues with it. I haven't even tested the analog portion of this effects processor yet. There could be issues there that I don't even know about at this point. But I didn't even bother hooking audio up to it because there was no reason to until I could actually be able to get into the menus and be able to switch algorithms and things like this. So I'm happy that I'm at this state right now, which is awesome. All right, real quick, I wanted to talk about what the issue was that I came across and how I was able to diagnose it down to this chip. Just in case other people have similar issues. That's probably what they're more interested in learning about anyway. So this chip was the one in question, U39. It's a 74HCT273 octal quad flip-flop, basically. D-type flip-flop. And there's 4 of these in the circuit, all driven off of the data bus from the master processor that have their individual selects. And they drive basically the vacuum fluorescent display drivers that actually drive the display right here. And that's what those 4 chips are. So probing these chips with a scope, I was noticing that, well, the data bus across all chips was low. That was the one observation I made. But the select pin coming from that other portion of the schematic right here, U59, this actually drives the display. So you've got the 2 segment selects, 0 and 1, and then also the second select here labeled digital select 0 and 1, and those pins all actually go over to these 4 chips here to actually drive it, and that's what clocks in the display and, you know, actually puts the characters in the display. Anyway, the select off here I noticed was, you know, looking at the outputs of this decoder, the 74138, the pin going to U39 in terms of the segment select 1 was low. It looked like the pins on the data bus, whereas the rest of the select pins looked normal. They were almost 5-volt rail-to-rail signal going on there. So that's what kind of drove me to this chip, because data bus was low, and then all the other select pins were fine except for this one, which was curious, and that is why I pulled that chip. And sure enough, after pulling this chip, the data bus is now operating correctly, the select pins are operating correctly, everything else seems happy. So this chip had failed, and that was what the issue was with the digital section of this device. So I've been looking for the 74273 octal flip-flop. I keep saying quad flip-flop, but it's actually an octal flip-flop chip, and I can't find any parts of it among any gear I have. I've got boxes of TTL logic and CMOS logic. I've got massive boards from Intergraph computers that are just completely full of TTL logic, all socketed too. I've got about 10 of these, all varying differences, different types, and none of them have that chip. So I'm gonna have to order one. I don't have one. Because of that, it's going to be a few days before I get them in. This is also, it's an HCT LS, which is kind of a weird hybrid, because it's HCT, which indicates CMOS, but also LS typically, which is your low power. So I didn't find one right away. I found HCTs and separate LSs. Either should be compatible with this. I might buy a couple different types just because I haven't been able to find this one, if I can't find this one, and we'll go from there. But it's going to be a few days before I get it in, so I think I'm going to stop this video here. This will be part 1 of this PCM 70 repair. It's going on quite a bit now anyway. This is going to be well over 30 minutes at this point. So I'll make a part 2 of this repair, which will go into the remainder of going through this unit and solving the slave processor problem. The error on displayed, by the way, I looked that up, and it was actually slave. It's what was it? Slave date error. I can't remember exactly, but it indicates the master processor is not communicating with the slave processor. So that should be an interesting one to troubleshoot as well. But so I'm gonna get that chip in, and then that'll be in the part 2 video replacing and going through the rest of this unit. So I hope you enjoyed watching this so far, and hopefully some of the information here is useful to you in repairing your PCM 70. Thanks for watching.